All right, so now let's look at common logarithms. So this is a logarithm with a base 10. So common logarithms are typically written as log x, just log of x. But it means log base 10 of x when you have it written like this. And so then we know for any x greater than 0, then what we can do is we can take now 10 to the y is equal to x. Okay, so before we just have to the base, whatever the base was, well, now our base is 10, so it's 10 to the y equals x. So we can eventually mentally evaluate what these mean by saying, okay, well, instead of seeing y equals log x, we're going to see log base 10 of x. So that's going to be what we're going to see from now on. So now we know it's going to be 10 to the y is equal to x. And so now we just, again, have to use our knowledge of powers, squared, cubed, roots, etc., to think about what powers of 10 need to be raised to in order to get to x. So let's think about this here. If we just have a 1 times 10 to the 0, what's that going to be? Well, 10 to the 0 is 1, so that gives us 1. And this is scientific notation, so that's kind of what I'm trying to get at here. And if we have 1 times 10 to the 1, well, 10 to the 1 is 10, times 1 is 10. Then we have 1 times 10 squared is 2 zeros. So as we go up, basically every time we have a number that's going to equal what we have. So 0, anything raised to the 0 is 1. If we have 10 raised to the 1, it's 10. 10 raised to the 2 is 100. Now, what if we go the other way? Well, if we have 1 times 10 to the negative 1, well, that's going to be 0.1 because we started here and we moved over a tenth, basically 1/10 over. So that's 0.1. If we have 1 times 10 to the negative 2, well, if we start with 1, now we move 1, 2 places, so we get 0.01. And if we have, 1 times 10 to the negative 5, well, again, we start with 1, and then we have some zeros here we're going to add because we know we're going to the negative. So we start here and we go 1, 2, 3, 4, 5. So it's going to be 0.0001. So we can think of this as that number minus 1 is how many or zeros are going to be, and then we have that 1 in front of it. So now let's work with that, going to these numbers here, evaluating mentally. Well, again, remember, this is log base 10, no matter how we want to look at it. So that's going to be 10 to the y is equal to 1 million. Okay. 1, 2, 3, 4, 5, 6. Yep. So what does y have to be equal to? Well, remember, whatever that number is how many zeros we had. So then y has to be 6. Now this one we have 10 to the y is equal to 0.001. Now remember, we just have to move our decimal to the right until we have 1 point. And so we go 1, 2, 3. So it's going to be y is equal to negative 3. Because to get back there from this point, we had to go left 3. So we go left 3. So it's a negative 3. And if we had to put in here, we could have had a 3, and that would have been 0.001. Now, what about this one? Well, we're not going to worry about this 7 part here. We're going to figure out what is log base 10 of 1 first. And so we'll take 10 to the y is equal to 1. Well, 10 to what is that? Well, 10 to the 0. That's a 0 then. And so in that case, y is equal to 0. Okay. So y equals 0 here, that's what that is equal to. So then plus 7. So this overall, if we want to evaluate this, it's going to be 0 plus 7. So that's equal to a 7. So we first basically solved what that was equal to. And if we kind of come up here, what was of 1, that was equal to that 0. And then we had to say, okay, then plus 7. So I kind of had to split that one into two little pieces. All right, so let's move to the next one. So now we can do these with calculators, okay? And we're going to do that using the strictly log key if it says log, okay? So what we're going to do is we're going to go and plug these into our calculator, and we're going to solve and see what we get. So our log button is right down here, log, and it's going to say log, so we know we got the right one. And now we're going to type in 421, okay? Now we get 2.624282096, and it said round to 4 decimal places, so that would be 2.6243. Okay, so I'll write that down. Now the next one said find the log of 713. Okay, well, type that in. We get 2.8531 if we're rounding to 4 decimal places. Now, we looked at positive numbers here. What if we wanted to plug in a negative? Now, do we remember our definition of logs? Basically, our x has to be greater than 0. So let's just try one. What if we wanted to try that negative 421? Okay, well, if we do that, non-real answer, and so it basically tells you you can't do that, and so we can't take a log of a negative, which is kind of what we knew anyway based on our definition that said, to find logs, x has to be greater than 0 because a log looks something like that, and so it's always to the right. It's not to the left, it's to the right. Okay, so we found here with our calculator 2.6243. Here we found that was equal to 2.8531. And then we said, okay, hey, well, let's do y equals the log of a negative 421. And it said, so that's undefined. We'll say is what that is equal to because x has to be greater than 0 to be actually working. Okay. All right, let's do a application problem here. So it says the amount of energy released from one earthquake was 8,500 times greater than the amount of energy released from another. The equation 10 to the x equals 8,500 represents this situation. So they've already written our equation for us. 10 to the x is equal to 8,500. Okay, where x is the difference in magnitudes on the Richter scale. To the nearest thousandth, what was the difference in magnitudes? Okay, well, guess what we're going to do? Well, before we had logs and then we wrote it as an exponential. Now we're going to write an exponential to a log and see if we can solve it. So that says log base 10, or we could just put log of, well, of what? 8,500 equals x. Okay. So now let's see what we get in our calculator because I don't know that off the top of my head for sure. And so we're going to take the log of 8,500, and when you have log, that's base 10. So 3.929, and does it say to the nearest thousandth? So that would be to the 3 decimals, and a 4 is not going to round it up, so 3.929. And that would be the difference in magnitudes. Okay, and so that one is 8,500 times greater than the one that was smaller, and that's a difference of 3.929 on the Richter scale. Okay, so looks small here, looks huge here. All right, let's stop here and we'll come back some more.